Welcome to this walkthrough of our data distribution with DataFlow Trial pattern. Thank you very much for taking the time to try out Cloudera DataFlow on CDP Public Cloud. In this walkthrough, I'm going to show you the 3 different use cases that we've implemented as part of the trial and how you can use all our DataFlow features to complete them and how it gives you a great idea of what DataFlow is capable to do for you in your enterprise. All right, so first of all, let's talk about what we're seeing here on the screen. So I have registered for a CDP trial and I've selected the data distribution with DataFlow pattern. Now, the next step for me here is really to get started, get into the product and start implementing my use cases. But this is really my homepage, and this page has all the resources I need. So one of the things you can find here is a link to the GitHub tutorial that would walk you through what we're seeing in this video, step by step, if you prefer to read. And then also up here, we can manage our trial. So we can extend the trial, we can end the trial. And also very important when we're building our flows, we will be able to access configuration information through this menu as well. All right, so with that out of the way, let's get going and let's jump right into the product. All right, so once we click on that link, we're right here in CDP. And now is the time when we start following our walkthrough in GitHub to implement our use cases. So before we go and do that and go step by step through what we're doing here, let's review our first use case and what we're trying to achieve. So our first use case represents a use case that is very common within our Cloudera customer base. In here, we have a stream coming in of devices that are generating syslog data, and they're being sent to a Kafka topic. Now, we want to work with that data in the Kafka topic. We want to filter out critical syslog events out of that huge stream of data, and we want to make that available in a new topic for some operational dashboarding needs, where we really only want to look at the critical events. So this is our use case. We're going to build a flow that reads these syslog events and writes them after filtering out the critical events. So let's go back to DataFlow and let's see how we achieve this. So first things first, we're going to pick our DataFlow data service here, and then we're being forwarded to our dashboard, our deployment dashboard here. Now on the dashboard, you should see one flow deployment already running. This is our data generator. So in this use case, we've deployed a flow that actually generates the syslog data. Feel free to click around here, explore this deployment. You can manage it. You can actually click all the way through to the NiFi canvas and see how this flow is generating the data. But this is really the source data that we're going to work with. So now what we're going to do is we're thrown into this product. We don't really know how things work. So let's just explore what we have here. Okay, so we're new to this product and we can click around. We can explore all the functionality that's in here. So for example, flow design sounds like I can create some new data flows from scratch. But remember, our goal was to read some data from a Kafka topic, filter it, and write it back again. So let's actually head over to the ReadyFlow gallery. And it seems like the ReadyFlow gallery has a lot of templates here for common data movement use cases in the cloud. You can see this is a pretty big library that really can help us getting started. So why don't we just search for Kafka and see what we find here in the ReadyFlow gallery? So there's several different flows. This one here, Kafka filter to Kafka, looks like it's doing exactly what we need it to do. So in order to take a closer look and actually now start customizing this to our needs, we're going to go ahead and select create a new draft, which will allow us to open this in our flow designer and customize the flow as we need it. So we're going to hit on the create button. And now we're being redirected to the flow designer. So this is the visual representation of our data flow that you can see it consists out of 3 processors. We have consume Kafka here, filter events processor, and write to Kafka here. So this looks pretty promising for us. And probably now we just have to adjust some parameter values in here to make this work for our use case. Now, one thing you'll notice here is this banner that recommends to start a test session. Now, what these test sessions do is right now I can build my flow, I can change properties of these processors, I can drag in some new components here. But if I want to test this with actual data, if I want to run these processors, I need a runtime. And that's exactly what these test sessions do. So I can start a test session here, and then DataFlow will spin up a NiFi runtime and will bind it to my session, so I can actually interactively interact with all these components here. So while this is starting up, let's take a look at our flow options and at our parameters. So the parameters here is really where we can customize this to our use case. So you see a lot of these parameters. So we have a username and a password. It's being used to authenticate to our Kafka system. Then we've got some connectivity information here, and then also information about where the schema is coming from. The majority of these values, they are, you can copy them over from the walkthrough in the GitHub repo. So I'm gonna do that right now. Our username. Now for some parameters like the password here, we actually have to go back to our trial homepage, and we can copy these values from here. So I'm gonna go into manage trial configuration, and then I'm gonna have my password right here for this user. So I'm gonna copy this over. And then we continue. So data input format, we're receiving data in Afro format, and we want to output it as JSON. So we're going to do some format conversion in this flow as well. Now, the filter rule here, you can see that this is a select star. So it will just basically let through all the events here. Now, okay, let's continue to our Kafka broker endpoints. Same story here. We go back and we copy the value for Kafka broker from our trial manager homepage. I'm gonna put all of that in here. Consumer group ID is gonna be CDF. Our Kafka destination topic is syslog critical. And our producer ID is CDF as well. Source topic is called syslog avrow. And then we are also looking up a schema called syslog. And same thing here again for the schema registry hostname, just copying this over from here. So now we've updated all those parameter values. So we're going to apply the changes. And now all of these components that you see here, our Kafka processors, filter event processors, etc., they're all being updated with those values. Now, at the same time, you may have noticed that this pill up here has turned green. So our test session is now active, which actually allows us to interact with our flow. So if we go back to the canvas, to the designer here, you can see that now we have a lot more colors here, right? These processors display a status that tell us about whether they're running or not. And now we also have some additional validations here. And this is telling us that some controller services are still disabled, which prevents us from actually now starting these processors. So what we're going to do now is we're going to go into flow options, into our services, and then we're going to start all of these controller services. So these controller services are reusable services that help us, for example, read messages, apply a schema to them, and in other cases, they connect to like our schema registry, for example. So in here, I can click this service, the CDP schema registry service, and then I'm going to hit enable service and referencing components, and this will turn on all of my services here. So now they should all be green, and we're going to go back to our canvas. Now you see all of these processors have been started, I'm actually going to stop those two, the filter events and write Kafka processor. And now what you see is that data starts to queue up here in this connection, right? So our consume Kafka processor is working. You can see some statistics about the throughput here. And the data that we're reading from Kafka is really being queued up here. Now let's take a look actually at this data. So we can right click here, go to list queue, and then we will see all the data that's being queued up in this connection. You can just pick a random item here, and now we can see a lot of information about the attributes here. So remember, we're reading from Kafka, so this is where all the metadata about our source, for example, is stored in those attributes. For example, we can see the Kafka topic name, we see the consumer ID, the partition this record came from. So this helps us identify the actual record. But we wanted to take a look at the actual data. So there's two ways I can do this. I can either download this file and look at it in my favorite editor, or I can open this in the built-in data viewer, and that's what we're going to do right now. I'm going to click on that, and now the data viewer is automatically going to recognize the format. This is JSON here, and it's going to render all of the events that are part of this one queued flow file here. So lots of events are part of this. You can see that the priority and severity is all over the place, and generally these are syslog-like messages that we have in here. All right, so let's go back here, and now let's actually look a bit closer at the flow. So remember, we wanted to filter out critical messages, right? So right now, we read all the syslog messages regardless of the severity. So now let's use this filter processor to actually filter out some records. So we can double click that processor, and the configuration pane appears. And now just look at the configuration properties, and you'll find a filtered events property right here. And that is configured with a parameter here as well. So let's take a look at what we're filtering here. So we're going to go to parameter, and then we see, okay, it's a select star from flow file. What this means is that it selects all records that are stored in this flow file. But we can now filter on any of the properties of the actual data in that flow file. So remember earlier when we looked at the data, we saw that one of the fields was called severity. So if we only want to have the most critical events here in our flow, we can now filter on that, and we can say, well, only let events through where severity is less or equal to. All right, so we're going to apply this. So this has been applied. We can now directly jump to our filter events processor here, and we can then go ahead and start it. Now this processor is running. It's going to start working on all these files that are being queued up here. And now you can see, all right, so we've got our filtered events here. And let's actually take another look at the data and see whether we filtered out the data as expected. So again, we're going to pick a random flow file here, and we're going to open it in the data viewer. Now what we're going to look for is the severity. And we should only see records with severity 2 or less. So first view 2, 2, 0, 0, 1, 1, 1, 1, 0. All right, so this seems to be working great, right? We only see the high severity that we wanted to pass through. So that's how easy it is to filter out records in DataFlow. Now, well, what is left? What is left is really sending the data to our critical Kafka topic. So we can take a look at this processor here and its configuration. You see we're using a lot of the parameters here again. The Kafka broker endpoints, our destination topics, these are all the things we filled out earlier in the parameters page. And with all of these informations, we can now just go ahead start this Kafka processor, and it's going to start running. It's going to start reading from this connection, and it's going to start writing these events to our Kafka topic. So if you don't see any errors here, things are working fine. We can see we've read 42 megabytes and they've been sent to our Kafka topic. So this is great. This is exactly what we need. And this is how we develop a flow in Cloudera DataFlow in the new DataFlow designer. Now that we've developed the flow, the next step is to actually take what we've built and deploy it in production, right? So what we're going to do is we're going to stop this test session here because we're done with developing and we've tested it in our dev environment and things seem to be working. And now we're taking it to our production environment. The way this works here is that we're going to go ahead and we are going to publish our modified flow here. Publishing so I'm going to just call this production. And then we can give it a description. All right. And publishing this flow now adds it to my central catalog. And as you can see already, we immediately pop out a sidebar that allows me to create a deployment for this particular flow. And this is exactly how you take something from development to production. So this deploy button, we're going to hit that now, is going to walk us through a deployment wizard that allows us to create a production grade deployment. So first of all, we're going to pick our target environment. So we only have one available in this trial, but this could be running on AWS or it could be running on Azure. So you can take a flow from the catalog, deploy it to any cloud provider. I'm going to hit continue. Now we're going to give that flow a name. I'm going to do critical syslogs prod. Move on to the next step. Now here we can configure our actual flow runtime. DataFlow is based on Apache NiFi. So here we can pick our NiFi version. And let's pick actually not the latest version. Let's pick one version before. So we can walk through another really great feature of DataFlow later. So we're going to pick the previous NiFi version. We're going to make sure start flow upon deployment is checked. And then we're going to move on. Now, the next step, we have to provide our parameters for this production deployment. So usually when you take something from development to production, the values for these parameters, they change because now you're not interacting with your dev systems, but you're interacting with your production systems. In our case, we were only working with one environment, so the values actually don't change, but we still have to re-enter our CDP workload user password here because sensitive information is always redacted from here. So we go back to our trial manager homepage, we copy this password, go back to our wizard, paste it in, and move on to the next step. Now here we can pick our preferred deployment size. So you can pick different sizes with DataFlow. Now we're going to go with extra small, but we're going to turn on autoscaling. Autoscaling is CPU based, so depending on how much data is coming in, how much processing power is required, it will automatically scale up between 1 and 3 nodes. And then we can also turn on flow metric scaling, which is a more intelligent way of scaling that actually looks at what's happening in your flow if data is queuing up at a specific step, and if it is, it will also start scaling up. So we're going to turn both of these things on. Now, in this step, we can define key performance indicators that help us monitor our flow deployment. So I'm going to add a new KPI. I want to know how much data we're writing to this Kafka topic. So I'm going to look at the entire flow, data out, and then I can also define alerts. And I can say whenever the metric is less than 1 megabyte for 1 minute, I want to get an alert. Next, we can add another processor, another KPI, and we can do that on any sort of scope here. So let's actually look at a specific processor. Let's look at the consume from Kafka. So this is how much we are reading from our source topic, and let's look at bytes received. And let's say we want to trigger an alert when the metric is less than 512 kilobytes for 30 seconds. Okay, so adding this KPI as well. We can add as many KPIs we want, so feel free to add more and explore what other metrics you can monitor here that are helpful for your flow deployment. All right, so final step, we can review all our inputs here, and we can also see what we've done here in the wizard. We can now take a look at what this would look like as a CLI command. So we can basically copy this one command here, and then 2 files for parameters and KPIs, and then with one single CLI command, you can recreate this deployment and all the steps that we've just completed in the wizard. All right, so for now, I'm just gonna hit the deploy button here, and we're gonna kick off this deployment. All right, so it looks like our deployment has succeeded. Creating that deployment may take a while, so we're provisioning basically the infrastructure on the fly as we need it. Then we provision the entire flow. So feel free to click around in the application as this deployment gets created. Now that it's created, let's take a look at what we're seeing here in the dashboard. So first of all, notice how we can adjust the metrics window on the dashboard. We can look back as far as 1 day, and we're going to see the rendering of these throughput graphs change accordingly. We can also filter here by the different status that our deployments have. If we have more than one environment, we can use that as filters, or we could also filter based on some processor types that these flows are using. So let's take a closer look at our deployment. So here we have 3 different tabs. KPIs show us information about the deployment, and then you can see those are exactly the 2 metrics that we defined during deployment that we now get an easy access to. And over time, we will see the metrics show up, and the graph is going to be populated. So it allows us to quickly see whether our flow is performing as expected. We can also check system metrics that will tell us the core allocation of the deployment and also the CPU utilization. So this gives us a good indication of how the resources are being used. So KPIs are now also getting data, and we can see how much we're writing out and the bytes that we're receiving from Kafka. Now, if we let this run here for a little bit, one of our KPI alerts will actually trigger, and you will see the status here change, and you'll see concerning health, and you'll be able to interact with that warning here and go to the alerts tab where all of our, historic deployment info events show up, and also where active alerts will be shown here for you to further explore. So while all of this is happening, let's take another look at the deployment, and we're gonna go into manage deployment, which takes us to a new page where we can update things of our deployment, right? We can update the parameters, we can change the sizing configurations, we can turn off auto scaling, we can increase the number of nodes, etc. We can also add new KPIs. A key feature here is the ability to go into the actual NiFi deployment. So this is if we need a deep dive into troubleshooting into our deployment, we can go in here. We see that process group running, and we see the same flow that's being now deployed on NiFi running on Kubernetes. So let's go back. A key feature here is also the ability to change the NiFi runtime version. So let's actually hit that button. And remember, in the beginning, when we created this deployment, we didn't choose the latest NiFi version. We chose the previous NiFi version, and we did that so that now we can upgrade to the latest NiFi version. So this deployment is running. We're just going to pick our latest version, and we're going to hit the update button. Now we're going to be redirected to the dashboard. The status changing it changes into updating, and now you can see how the dashboard always tells us exactly what's happening. We can check out the details, and it's going to tell us, okay, we're updating the NiFi version right now. And also, by the way, one of your KPI thresholds has been breached, and it's because the data that we send to the external source, that we send to the destination, is less than the boundary that we have defined. So with that, we've now created our production deployment. We have explored how to monitor it, and we're currently updating the NiFi version. So it's really as simple as that, creating your production deployment with the wizard, and now updating the NiFi version. So with that, we have come to the end of use case 1. Thank you very much for sticking around with us. I hope you enjoyed this and you're ready to move on to use case 2. Welcome to use case 2 of our DataFlow trial experience. Remember, in our first use case, we deployed a flow, we developed and deployed a flow that reads data from a Kafka syslog topic, filters out critical events, and forwards them to a destination topic. So now, one of our coworkers has asked us to also persist those critical events in our data lakehouse. And we're actually right now evaluating an open data lakehouse approach based on Apache Iceberg. They've already created a table in that open lakehouse for these syslog events, and they've asked us to ingest them into that Iceberg table. So we're going to take a look at how we can achieve this with Cloudera DataFlow, and we're going to specifically implement this second part here that takes our critical events from this topic and writes them into Iceberg. So without further ado, let's get going. So we're back in DataFlow here. And as you might have guessed, we will start this use case just like we started our first use case. So we'll go to the ready flow gallery. And instead of Kafka this time, let's actually search for Iceberg, see if there's a ready flow for that. And guess what? There's a ready flow that helps us to take data from Kafka and write it to an Iceberg table. So let's take a closer look at that, and let's create a new draft and open it in our flow designer. So we're going to create the draft, and now just like before, the flow is being opened in the data flow designer, and we can take a closer look. So the flow consists of 3 processes as well: consuming data from Kafka, we are merging records together, and then we're writing them to Iceberg. So this merge records processor here helps us to optimize the throughput to Iceberg, because it prevents us from writing, individual events into the destination table, gives us control about how much we want to batch up these events. So you can really control if speed is of the utmost important to you, or whether it's then the actual throughput and performance of the ingest. Now, just like before, we're going to start a test session here to make sure we can later interact with this particular flow. And then we are going to go ahead and we're going to start configuring our configure our parameters here. So our CDP workload user, we can copy that from the tutorial. Then we need to get our password. Again, we go to the trial manager homepage, get the password. Our data input format here now is JSON, because previously we wrote our events in a JSON format to the topic. Our Hive catalog namespace, let's actually syslog. That's where our coworkers created a table. And the table is called syslog critical. Our Kafka broker endpoints where we're reading from. I'm going to take this value from here. Our Kafka consumer group is going to be CDF. And our source topic, this time, syslog critical. That's where all our critical events are. And again, we're going to use the syslog schema name. And we're going to take our schema registry hostname from here and plug that right in here. So with all of this, let's go ahead and apply our changes. And we have set our parameter values. So our test session is still starting. So we can't start and stop all of our services yet, but we can already modify our flow. So right now, the challenge is that our coworkers, unfortunately, when they created the table in Iceberg, they used a slightly different schema than what we are receiving in our event stream. So we have to do some transformation now. We have to rename some fields, and we may be dropping some fields. So we have to extend this flow here. The way we're doing this is we're going to drag a new processor to the canvas, and we're going to use our Jolt Transform record. I'm going to call it Transform Schema, because that's what we're doing. And we're just adding it to the canvas like this. Okay? So the next step is that we create our connections now. So we want to transform the schema before we merge these records together. So we're going to go ahead, connect these two processes together, and we're going to pick the success relationship. That's where all our Kafka events that we receive will be sent to. And then we're doing the same thing here from transform schema to merge records. And also here, we're going to pick the success relationship, which is going to contain the successfully transformed records. You can also see that we can actually do something with these other relationships. So we could now create another connection to another processor and say, okay, so this is where we want all the failure events to go. This is how you can treat, you can create different paths in your flow for successful events or events where a transformation failed. Okay, but we're gonna remove this connection again because we actually don't need it in our real flow. So I'm gonna delete this, and you can see that in the meantime our test session has started. So now we're back in interactive mode where we can start and stop these processors. We also need to delete our original connection here because we don't want these original events from Kafka going into the merge record processor. We only want the transformed records. So I'm going to make sure these processes are stopped, and then I can remove this connection here as well. Now that we've done that, let's head over to our controller services and let's start them as well. So we're going to start with our schema registry again, start all of these services, and then we're just going to go from the top to the bottom, starting the remaining services that were not dependent on the schema registry. All right, so we've started the services, we started the processor, and the first consume Kafka processor is running. And now what we have to do is we actually have to configure our schema transformation. So the first thing we have to do here is actually, so we have two properties here, a record reader that defines how we're going to read the events, what schema we're going to apply so that we can then modify them, and a record writer that says how do we want these events to be written out into this next connection. So we need a new record writer that uses the schema of our destination table. So I'm going to go in here and I'm going to say add service, and I'm going to pick an Afro record set writer. So we're going to do this in Afro, and then I'm going to give this service a name. And the name is going to be transformed schema writer. All right, so now we've added it here. Now we have to configure it. So I'm just going to go here to the actions menu, go to service, forgot to apply, go to service. And now here I need to configure it. So the first thing is our schema write strategy. We're just going to embed our Afro schema. That's easiest to work on downstream. But then in order to access the schema, we're actually going to use our schema registry. So we're going to put that to schema name. We're going to pick our CDP schema registry. And the schema name is now syslog transformed. So this is our destination, our target schema. And now we're going to apply. Now we have hard-coded the schema name here, which is not ideal. It works for a test, but in order to make this really production grade and easily adjustable in the future, we should convert this to a parameter. We can go to the actions menu here, hit convert to parameter, and then we're just going to give this a name. Schema name already exists. I'm going to call it schema name transformed. It's going to have the value syslog transformed. We're going to add it, and we are going to apply. Now, down here, we can see the processors that reference our controller service. So we can easily navigate back to our transform schema processor. And from here, we can continue configuring the processor. So our record reader is going to be this Afro reader that already exists. It just reads the default data coming from Kafka. And now the way we transform this is using a Jolt specification. This is transformation language. This is a transformation language, allows you to transform data. And we're just going to copy the specification from the GitHub tutorial into here. You can see that we're doing a shift. So we're renaming things. We're renaming app name, making it all lowercase. And then we're also changing the timestamp field to event timestamp. And we're also lower casing a few other fields here. So let's hit OK here. We're going to apply our changes. I forgot to terminate so I just applied our changes, but still can't start the processor because it has some validation errors. Now here it's telling me, oh wow, you need to do something about your relationships. They've not been connected or terminated. So let's do that first. I'm going to terminate failure in original. I'm going to apply that. Now there's only one validation issue left. Our schema writer is disabled, so we forgot to enable that earlier, but we can just click here. It's going to take us to the controller service. We enabled it, and if we go back, we should be ready to go. We are. So let's go ahead and let's start our transform schema processor. Now we've already processed all these events that had queued up. So just like before, we're going to take a closer look. And we're going to see if our transformation was successful. So we're now look like that the data viewer detected the format automatically, and it detected an Afro format, and it renders everything in a human readable format. So this is very nice. It makes it easy for me to understand whether my transformations are working or not. And if we remember what we did, we transformed the timestamp field to event timestamp, and then we transformed other fields here to all lowercase: event ID, event source, and IUT, for example. So all of this seems to have worked. It's looking great, and we are confident that our transformations are working as expected. So the data viewer and this ability to really look at the data between each processing step is really critical for interactive flow development and makes my life so much easier because I can immediately troubleshoot, see what's happening without having to deploy a full flow and then troubleshoot what the issue may be. So we're going to go ahead. I'm going to start our merge records processor. In here, you can configure this processor. By default, in this ready flow, it's set to a maximum bin age of 5 minutes. So it'll actually it'll queue up records for up to 5 minutes and then merge them all together. If you want to speed that up a little bit for this trial, you can also change it to something like 30 seconds. So let's do that. I'm gonna apply this change, and now we're gonna start this processor. So one way to start the processors is also up here in this bar, action bar. Now it's running. It's gonna merge all these things together. So now the final step is writing the data to Iceberg. We have a put Iceberg processor that we're using here, and when we explore the properties, you can see how our parameters are being used, our Iceberg table name, our Hive catalog namespace that we've input before, and that's really all we need to do here to configure this Iceberg processor. So now we can go ahead. We can also start this processor. Now actually we have the first file here that was merged together. It's 17 megabytes. So we're gonna start this processor here, and now it's gonna take this file and it's gonna ingest it into Iceberg. All right, so actually it looks like I'm getting some errors here. So it's telling me the table doesn't exist that I specified. So let's actually double check the parameter values here. Let's just make sure I've entered everything correctly. The Iceberg table name, syslog critical. Okay, it's supposed to be syslog critical archive. So let's see after applying these changes, and it's going to automatically restart my Iceberg processor. And yeah, let's go back to the flow and see what happens if we now can write successfully. So we see these failures queuing up here. The queue is decreasing. So now it seems like the Iceberg processor, it can successfully write to our table. So it was just a typo in the table name. We're processing the data as we want to. All right, with that, congratulations on completing use case number 2, where we took a ready flow from the gallery and we enhanced it with our own schema transformation here to make sure we can write our critical events to a table in Iceberg for further analysis. Feel free to go ahead, publish the flow, and create a deployment just like we did in use case 1. But this completes our use case 2. Thank you for joining us. Thank you for sticking around. And I hope we'll hear each other again for the walkthrough of use case 3. Welcome back to use case 3 of our DataFlow trial pattern. In this use case, we're actually going to do something different than what we've done in the first 2. And specifically in the first 2 use cases, you have seen us use the DataFlow designer to build our flow. We tested it interactively, and then we created a deployment based on our flow definition that could auto-scale and that we could monitor, and all of that was managed in DataFlow. Now, these kind of deployments are great when we have data coming in, it's constantly streaming, and we need elasticity up and down. There are plenty of other use cases where data arrives much less frequently, and we want to trigger our flow based on some event that happens. So for these event-driven workloads, DataFlow offers DataFlow functions, which allows you to run these flows that we've designed in a trigger-based fashion. What we'll see in use case 3 is a data flow that will react to an HTTP API being called, will receive an event, and then will parse the data, will resize an image, and will return the resized image back to the client. So we're basically building a image resize service using DataFlow in the public cloud. So let's take a look at how all of this works. All right, so in DataFlow, you have 2 options now. The GitHub tutorial walks you through building the function from scratch. So you can go in here into flow design, create your new draft and then follow the steps for you to create your function. The alternative is to go to the catalog and find the use case 3 flow definition in here, resize image function, and you can open that flow also in the flow designer by creating a new draft, and we can take a look at it like this. So let's create this draft, and then we're gonna see what this function looks like. So the function starts with an input port. That's very important. In our previous 2 flows that we've built, we always started our flow with a processor because we're reading some data from a source. Now in this use case, later our cloud provider, and in our example AWS, will send us the HTTP request through this input port. So we got to receive the request and the body and all the content through this connection. Now the first thing that we have to do is we have to parse that message, and we have to parse that content. That's what we're doing in these first 2 processors. And then we are decoding the content, we are resizing the image. You can see the processor configuration. We have two variables here that we will set later on. We're encoding the content. Then we are adding some information to our reply. And then last but not least, we are sending the resized image back to an output port. So again, for this function, it's very important that you always start with an input port, and then we end with an output port. And we're gonna, that's how all of this is connected in this use case. So now that we know what this flow looks like, now it's about how do we make this run? How do we get this deployed in our cloud provider? So I'm going to walk you through how this works in AWS. So we're going to go back first to our catalog. So this is the flow that we used, that we opened in the canvas. So we're going to go back here. And what we need to do is we need to copy this flow version CRN. So we need this later to invoke this function using our CLI. So now in the GitHub tutorial, you basically have completed all the steps to build the flow. And now the next steps here is to download the NiFi binary. So after copying this flow version CRN, we need to download our binaries that we can use in the function configuration to execute all of this. So we're going to go to the functions page here. And now, depending on the cloud provider you want to use, I'm going to walk you through AWS. We have tutorials for Azure and Google Cloud Functions as well. So just follow the documentation links here, and then you can actually walk through the same example on these cloud providers as well. So I'm going to hit the download button. This will download a NiFi binary that's optimized for running in these environments. Okay, so once we've done this, now we're going to configure our function. So now we have retrieved the binary, and we have built and we have retrieved the flow that we want to execute as a function. Now we have 2 ways forward. Number 1 is we're following the tutorial, we're walking through the AWS console, and we are going to create our function through the UI. The other option is, and I'm gonna show you this here, is us using the terminal and the AWS CLI to get this function deployed. All right, so what we're now doing is we're setting some environment variables that we need to create our function. So we've downloaded the binary. So now we're gonna set a variable called file key. And this is gonna point to our binary that we just downloaded. We're gonna set our location This is going to be US West 2 for me. You need to adjust this to match your region. Then we will define our bucket. So bucket name. Let's call this df trial function. Df trial function. Our function name is going to be resize image trial. And then our flow CRN. This is going to be our value here from the catalog. So we're going to go here, copy that CRN back to our terminal. And now our df access key. So this allows us to programmatically access the catalog where the flow definition is stored. To obtain that credential, we go back to our trial manager homepage, and there's a DFF service account CDP access key. I'm going to copy that. I'm going to go back here, paste it, and then we do the same for our DF private key. Private key. And there we go. All right, so now we've set all our environment variables. The next step is to download a function template, which I've already done in the backend, and that's what you see in my folder here. So the my function definition JSON, that is the function template. So I've done that. The next step is to create my S3 bucket. So I'm gonna copy this command here from our documentation. So this creates our S3 bucket. It uses the environment variables that we've just defined. So let's run that. Prerequisite is that we have set up our AWS CLI up front with a user or role that has the permissions to create new buckets and to perform all these steps. So now we're going to upload the NiFi, the functions binary that we downloaded. So it's just going to copy this. It's going to take the file path, and then we're going to upload it to our S3 location. All right, so upload succeeded. Now we need to create an AWS IAM role for this function. So we're creating this. I've copied it as well from the documentation. So I'm going to execute this. All right, so this worked. Now the final step is to actually create the function. So now we will invoke the create function command using the AWS API and CLI, and we will configure it with all these parameters, all these environment variables that we've provided before. Okay, so I'm going to run this. And I need to adjust this to match my path here. So ours is trial use case 3 / my function definition. All right, so now we're getting the response back from AWS. So we've successfully created our function. Now the final step is to add the trigger and then send a test event to our function. So in order to do this, we actually have to switch over to the AWS console. So that's what we're going to do next. We're going to switch over to the AWS console. All right, so here we are in our AWS console. You can see we've navigated to the Lambda section. And in here, we have our function resize image trial that we created 1 minute ago. So this represents all the things we've done on the CLI. Now, if we look into here, you see the function has been created. We actually have our code uploaded here. We have our NiFi handler. All of this is configured. If we go to configuration and to the environment variables, we'll see all of these variables that we've provided when we created the function. Now, the only thing that's missing is a trigger. And remember, we wanted an HTTP trigger that will allow us to send requests with images to this API. So we're going to add this trigger. And then for the trigger configuration, we're going to select API gateway. Now we're going to create a new API, and we're going to create an HTTP API. And for our test, this is just going to be an open API endpoint. So we're going to add this. All right, now we have the trigger that's been added to the function. And now we can get our endpoint right here. So this is the endpoint that we can call with any client. We can do this with curl. We can use Postman to do it. So I'll show you now an example of calling this endpoint and how we can actually use it to resize an image. All right, so to test our function, we're going to invoke it using curl. So I'm copying this from our documentation. Now I have to update our endpoint with our function, our API gateway endpoint here. So I'm going to copy this, go back here. So it is an image PNG. We're going to leave these width and height configurations. And then ours is image.png. And it is stored in the trial use case 3 folder. And that's also where we want the resized stored. So this is going to be trial use case 3 resized image. All right, so we're going to send this to our endpoint. All right, so this completed. If you run this the first time, this may time out due to the cold start limitations. The first time these functions get invoked, they have to download the binary, get set up. The API gateway has a 30-second timeout. So if you see this stop at exactly 30 seconds, that's most likely it. So just run it again, and then actually the resize will go through. So now what we can do is we just take a look at our folder, and we see there's a resized image PNG in here. We can also take a look at this resized image. And right here in the Finder, so we have the actual image, which is 120 kilobytes, and then the resized image, which is way smaller. All right, so with that, we have used our function to resize this image. And now what we also can do in the AWS console, we can monitor the invocations. So if you navigate over here to the monitor tab in the Lambda function, you can see, all right, so we got invocations here, and then here we see the duration. So this was the one that most likely timed out, and then we have one here, the latest one that was very fast. We have some failures here, so these were the ones that timed out. So yeah, all of that ties into the functions monitoring. If we want to have more details, we can take a look at the CloudWatch logs here. These will, if you're a NiFi user, these will look familiar because this is basically the NiFi log. So you can really see what's happening, how the function is being set up, and then how it's processing the files that we're uploading. So with that, we've completed our use case number 3. We built a function using DataFlow Designer Then we use the AWS CLI and AWS Lambda to set our flow up as a function, and we invoked it using an HTTP endpoint and sending an image to it that we wanted to have resized. So we built a quick image resize service using Cloudera DataFlow. So with that, we're at the end of our tutorials, our trial tutorials. I hope you've enjoyed walking through all of them. For now, please enjoy the rest of your trial. Feel free to build new use cases, start exploring, start trying out things. And we hope you're enjoying your trial and hope to hear from you soon. Thank you very much for your time.